Hello, everybody. Welcome to my new series I'm calling Mindset of Developer, where we reverse engineer games in ways that are easy to understand to give you an idea of how a project can go. My name is JJ Sachs. You may know me better as Jared. Today, we're going to look at the classic game Minesweeper. So I'm going to go over some expectations at the beginning in a quick PowerPoint as we're seeing here. You can skip ahead if you want to go straight into the game development. Timestamps will be posted in the description. I'll put a little timestamp right here for you so you know where to skip to as well if you do really want to go through there. But I want to go ahead and set some expectations up front here. So, a little bit about me. I've been programming non-professionally for about 7 years. I don't have any computer science degree or anything like that. I do plan on going to college very soon, hopefully, to get a computer science degree because it's something I'm really passionate about. I started with a Minecraft mod called Computercraft, as many of you viewers already know. I've worked at call centers for 5 years. I bring that up just because there's things that you can do with your programming experience that can even help you in a call center environment. For one of the call centers I worked at, I developed notation software and troubleshooting guides for them to help them out. And that's just with a non-computer science degree and something that helped me out with my job performance. So the goals of today, we want to go ahead and prepare your mindset to start your projects. You want to make sure that you know what to think about before you really get started. You know, things, what variables you need to get in place, how you're going to structure it long term, and really get prepared before you start laying down some code. I want you to learn how to structure your workflow throughout the entire thing. I want to give you a baseline of what to expect as you program, as I mentioned before, and I want it to be easy for beginners and even intermediate developers to understand. So today is not going to be about showing you the best way to do anything. There's going to be a lot of things that I'm doing here that they're just not going to be the best way to do it. There's some more advanced concepts, metatables, or Lua's version of object orientation. I'm not going to be using anything like that just to keep it simple. I'm also not going to be teaching you the basics of Lua or standard programming methods. If you want to see some of that, let me know so I can gauge if it's going to be worth doing maybe a tutorial series or something like that for really new programmers. If you're interested in that, let me know, and perhaps I'll do it if there's enough demand. But there's a lot of resources out there for you as well. And I'm not going to be speeding through the creation of Minesweeper. I want to take this a little slow so you can kind of think about my mindset and how I'm really going through every little step. I will be skipping over some spots inevitably just to speed up the video a little bit and make things a little bit more interesting. But the big parts are going to be right there for you. So why Minesweeper? I think Minesweeper is a really great idea for a starter project for you, or even if you're through a little bit but you want to think about things in a little bit new way, and that's why you're watching this video. Minesweeper has some simple rules that will align your expectations of how it is to be a developer. It really has you think about step-by-step sequential action. So if this number is this, that means there's this number of mines around it. It's kind of what that means. It's got simple graphic choices, nothing too exciting there, but it's an easy enough starting point. It's a fairly easy project overall. So I'm making this series because I know that when I was beginning, I was looking up things on wikis all the time, and I just wasn't sure if I was doing things right. I felt I might be going a little slower or not really doing things the correct way for my level. And more I get into programming, the more I realize that it's good to have the wiki in the background at all times. It's really helpful, even on things that you use all the time. Just make sure you're doing it right if you have any questions on it. Programming can help you automate things in your life. There's been things that I've done that makes things way faster for me. There's some really tedious things I do whenever I start my computer. I open up Chrome and I open up several tabs. It's always the same. So instead, I made a little Python script to just quickly do that, and it's just saved a few seconds on my life. Plus, it was a pretty fun project. But you can find things in your life that you can really automate, make things a little bit faster and easier for you. It's a skill that's in high demand. There's a reason that software developers and engineers get paid so much money. It's in high demand, and it's a very valuable skill. And I'm a firm believer that all the world's problems, at least most of them, can be solved by computers and good developers. So this is your first step. It's never too late to get started. The best time to start is now if you haven't started yet. All right, so we're here on Google's implementation of Minesweeper. I just Googled Minesweeper in Google, and it came up right there. That's how I got to this. This is actually one of my favorite implementations of it. It's fantastic. I love it. We're not going to be doing everything that it has, but we're going to be doing most of what it has. So let's go ahead and just take a look at it from before we even start the game, see what we can learn. So it has a menu here of easy, medium, hard, so you know how many mines, how large it is, and easy is a smaller field with less mines. Here's the mine counter right here. This is a timer. You can go to medium, has a larger playing field with 4 times the mines. And hard, lo and behold, it is bigger with more mines. So I'm just going to go ahead and start a game with medium. So if I hover over things, you'll notice that's giving me an idea where my cursor is. It's not a box around my cursor, it's a box over which one I'm hovering. So that's a nice little detail it has. It has a nice grid on it that makes things a little bit easy to see where a tile is beforehand. Let's go ahead and click on a spot. Now, I happen to know that every single time you start a game, your first click will be a blank spot. It's not going to have a number. It's not going to have a mine, of course. So you'll notice that whenever I do that, it's going to open up a big chunk of area for you. Just like that. So it has a nice little sound effect. There's several sound effects within the game. Sound effects are kind of hard to find for free, so I may not have very many sound effects with this, but I'll show you how to do it at least. So let's take a look at our options here. This isn't the easiest of starts. Most of the time you'll have a little bit more of a jig-a-jag pattern, so it's a lot easier. But let's go ahead and just take a look. I will play one game where I win and one game where I fail. I'm going to try to win this one. Let's see how well I do. So what the number means is that there is 1 mine around the adjacent ones, including diagonals. I'm just going to go ahead and just do that one, and I'm going to do this one. There we go. So we know that's a mine. So left click mines a little spot, and right click will flag it, saying this is where I think a mine is going to go. You can flag anywhere. It doesn't matter if there's a mine there or not. It's just saying this is where I think one is. And so we know that one's there because that's the only adjacent one, and it's saying that there's one there. So if I go ahead and click on one of these and right click at the same time, and there's the equivalent amount of flags around it as the number indicates. So this one, if I would left click and right click right here, it would mine out the adjacent unmined ones without a flag. But if there's say a flag here and there's only one flag but there's more than a number like this situation right here, this implementation will just say, hey, these are the areas that it will mine out once there's these are the adjacent ones that aren't flagged essentially. So let's go ahead and continue. Another nice thing there, whenever you see a spot where there is a lot of little blank spots like this, it will go ahead and automatically mine out a whole area for you. You're not going to have to go through every single one. And once you finish a game, it'll tell you what your highest score is, what your score this round was, as well as give you the option to play again. Now let's go ahead and try it again, but let's go ahead and intentionally lose so we can see what happens when you get that. So we know that there's a bomb right here. So let's go ahead and listen for what happens and take a look at animation, see what we can learn here. So you get a little, you get some particle effects happening. Get some. It's not all bombs explode at once. You kind of see it cascading through it over time. So it's you get a lot of little colors for that. It doesn't necessarily say which one you clicked on, which is something that I will do, but it does have different colors, which is something I'm not going to do. But you can make your own decisions on how you want to make the game. I just have a preset sprite sheet that I'm going to be using that I created a little earlier. So let's go ahead and jump into actual programming, and let's get started, see what we need to do. So to start off every project, I think about how the world is going to look, whether it be a grid like we're seeing here, or we're thinking about say a 2D platformer. What we're going to be starting with is the world that you're going to be playing in. Here we're doing the tiles. So I'm starting off by doing a 2D array of our X and Y positions of our tiles. Whenever you're thinking about your projects, it's also a very good idea to think about things that's going to make your life a little bit easier. What I did here was make a quick function that will do the math on the location in pixels of the top left of our desired tile image is going to be. And we're going to assign that to a quad. Sprite map dot hidden. Let's go ahead and just start everything with that. Now let's come over here. Let's keep this loop because we're going to need it again. But instead of this, I'm just going to index through it, and we're going to draw .img. There we go. So quick cut, I'm coming up here because I realized that I forgot these. I haven't run it yet, but have no need to run it. So you can put a comma at the end in Lua, but I'm going to take that out because we don't need any more. X, Y times grid tile size. And then let's see what happens. I know that for a fact that this is going to be wrong, but at least be able to see where we're at. Let's see here. So we got drawable expected, got quad. I know exactly why, because we need to pass in sprite sheet first. There we go. So, hey, whoa, what's happening here? So we're having a bunch of black lines between. That's exactly what I was expecting to happen. But what's happening is remember that the tile size that we're using to draw is 30 pixels, where the actual sprite itself is only 20 pixels per thing. So we're going to need to go ahead and do some scaling. So if we come back over to our wiki, we'll be able to go to graphics, to draw, and you'll see that the next ones that we're going to be looking at, we have the rotation that we don't have yet, so we need to pass in a rotation, which 0 is its default. And then we have scale X and scale Y. We're not going to have to worry about any of these throughout this one, but that's if you want to know about that, here's what they are. Okay, so the way that we do this is we go to grid.tilesize divided by 20. Let's do, I think it'll default to this one. Let's go ahead and try to run it and see if I'm correct on that. I am not correct on that because I forgot the 0. There we go. So we can see that now it lines up a lot better. But we have a bunch of black lines around here, so let's go ahead and correct that. I think that'll do. So if we run it, we'll be able to see that, hey, it shrinks down to exactly how large it needs to be. We're missing our forehead, though. We need to go ahead and get our extra on top that we are going to be putting different information bits on. So let's go ahead and use the Love2D coordinate system for that. Let's do lg.push, which basically saves the graphic state as it is in the coordinate system. lg.pop, which goes ahead and restores the graphic system that was saved inside push. So we're going to translate it, which means just move it around 0 to header height. There we go. So we'll be able to see that, but it's still not going to be right because we need to say right here plus header height. And now we're going to see we have that forehead. Now let's say what do we want to go ahead and do next? It's a little bit boring still. We're not seeing that outline of where we're at. Let's make a quick function here. Okay, just a quick collision detection. We have basically point X, point Y, and these are for the rectangles X, Y, width, and height, and it just gives us quick return on if the point is inside the rectangle. Inverse transform point. That's correct, right? Yes. Okay, position. That's a function. All right, so one thing I'm noticing is that I'm indexing grid for tile size, repeatedly here, and it's especially bad because I'm inside a double for loop. So I'm going to go ahead and do a quick alias here. That way we can switch around all of these for TS, make things easier to read, as well as be a little bit faster. It's negligible, to be honest, but it's a good idea to keep that in mind as you're programming, or else for bigger and larger programs, you're going to see it start to actually impact performance a little bit. So if I'm not mistaken, that should give us a nice little idea of where we are at. We did go ahead and mess up the colors a little bit, but that's okay. I can fix that, but it is highlighting exactly where we're at. And not over the cursor, but the tile that we're hovering over. Why it's a little darker is because I need to set this back to a bunch of 1s. Let's see here. So one thing I noticed just now, I'll go ahead and run it again. I don't like how that's black. So there's two ways that we could do that. We could either draw a separate rectangle with the color being set beforehand, or we can set it as the background color, which it's going to draw anyway. Might as well just set it there once and let love itself do its thing. So we have our cursor showing where we're at. We have our grid being shown. Now let's go ahead and let's put some action in this. Let's go ahead and do our love.mouse pressed inside this instead of if it's down inside update. That way it's only doing it once. So there's two different actions. If you remember, there's left click and right click. So let's start with the right click. Let's start with a flag. Now it doesn't make sense to be able to put a flag down if the map has not been initialized yet, so you can see me here putting a initialized variable inside my grid table, as well as creating the basic if statements to tell which button I'm pressing. So I was originally concerned that I was having if not grid.init in both statements, but after thinking about it, I don't think I'm going to change it because we need the grid to be initialized to place a flag with a button 2, but button 1 you can have the grid not initialized yet, so we need to be able to have that separate. So I'm going to keep it as it is for now at least. There are two ways that you can find what button you're hovering over. You could either loop through all of the tiles there and see if you're in the tile that you're in like we did in our draw function, or you can make a quick algorithm to return exactly where you are. We did it as the loop before inside our draw function because we needed to do that anyway to draw the tiles. We don't want to do that here because we only need to do a single action for a single one here. So what we're going to do is we're going to make the algorithm because that's the clear winner. Here you see we got the floor of our position divided by our tile size of 30. And I'm also going to go ahead and move this up to its own function so we can reference it at other times if we need to. Let's try that, see what happens. We're not crashing. Right click, and oh, hey, ooh, that is wrong. That is wrong. Aha, yep, that's why. There we go. That should fix it. Flag, yes. And you're noticing that no matter where I'm at in the tile, it's always choosing the correct tile to flag. But I did this the wrong way around, but that's fine. It was good for testing. It worked out, but we should not have been seeing those flags in the way that I was actually intending to do it. Let's go ahead and now jump into creating our map. And let's pass it in the X and Y position that we're at. That way, when we're creating the map, we can make sure we're not hitting a mine and we're hitting a blank space. One thing I'll do real quick, grid.init equals true. So we can set it to true right away. That way we can start placing flags and doing our thing. So coming up here, we need to go ahead and start creating our map. We're doing this in a while loop so it doesn't create a mine too close to our mouse, as well as it doesn't overwrite a mine that already exists and give us an incorrect count. At this point, I decided to redo how images are saved in my grid to string index points for our sprite map. This way we can easily tell what the image currently is for things like toggling the flag from a flag image to a hidden image. Alright, so that should give us, if I'm thinking about this right here, what this is going to do is it's going to say, hey, the image of this tile is going to be equal to this equation. If it is currently set to flag, it'll be hidden. If it's currently set to hidden, it'll be flag. Let's go ahead and see if that works. There we go. So we can put it on, take it off, put it on, take it off. So I'll have to think about if this is the best way to do it. It works for now, so I'm going to leave it, but we may end up changing it around a little bit. It seems a little bit complicated for what we're trying to do, but we'll mess with it as we need. Let's go back up to creating the map. Now to show you a problem that we're going to run into, I'm going to go ahead and reveal the mines, and I'm also going to show what happens if I click the same tile each time. It's going to provide you the same pattern here. So you can see here is diagonals. Next time it ran, here's diagonals, and another time, here's diagonals. Now we can change that by putting in a random seed when the game loads by setting math.randomSeed, and I'll just do a quick love.timer.getTime. At this point, I need to do a little bit of refactoring. The point of this series is to have the developer mindset, and a very important part of that is to stay flexible. You won't always know everything about making a program until you do it. I realize I need to index SpriteMap to get to ADJ and then the number. Much better to index it directly with the number, so I'll remove ADJ, be gone, and I'm going to remove this, be gone. Now I'll make an equation in our draw function to hide tiles depending on if it's revealed. Now I need to reveal the tile that I click on as well as set the entire map. So the first step is to create the mines, which we already have. Next I need to set the mine texture to the correct sprite section. Then I also need to go ahead and go through the entire grid and make sure that I get the adjacent mines to each tile. I'm making sure I skip over tiles that have mines so I don't overwrite those, as well as I am doing an adjacent function here to get the number that needs to go in that slot depending on how many adjacent mines there are to that tile. The next thing you want to do is you want to go ahead and run your code and find that you made a ton of mistakes and laugh at yourself because they're all really stupid mistakes, and it happens. It happens more than I'd like to admit. I don't know where it's getting these numbers from. 7, 8, 8. This is wrong. This is clearly wrong. Let's see. So now what you're going to do is, instead of fixing that big bug, you're going to get distracted by a squirrel and then change a smaller problem that you're having. So what we're seeing right now with our current implementation is whenever we place a flag, we're actually overwriting the image. We're not actually just flagging it or unflagging it. The image of a mine could become an image of a flag or blank, which we don't want. So we need to use our revealed variable as well as create a flagged variable, which you see me doing here. So here I fixed two separate bugs. The first one was whenever I was clicking in the header, it was crashing because it was trying to index a Y value that's lower than 0, and 0 was our lowest one that we created, so it's coming up nil. So I canceled any mouse clicks that happened if the mouse was above the bottom part of the header. Then I fixed the bug where it wasn't showing the mines. I forgot to set the mine texture, as well as I had a typo where I was saying Y plus Y, so that's what I changed here. Let's go ahead and run it so we can see how we're looking. So if we find a number, if there's a mine, we should see at least some ones around here. So these ones are matching. That means we know there's none here. We know there are none here. That means that this is all working just as we'd expect. Next big move that we're going to be making is every time we open up a tile that has nothing on it here, we're going to want to cascade through it and open up all the other blank tiles and those adjacent to it. Now there are a few ways that you can accomplish this depending on how you want your end result to be. I want to have a nice little animation on mine, so I'm going to put mine in love.update, where if you want to have this happen all at once and instantly have an open grid, then you're going to want to put this in somewhere that's only going to happen a single time. Neither one are necessarily better, it just really depends on how you want your end product to be. Now I just wanted to start by making this work. So what I did is I took the X and Y position, I looped through every point in the grid. Now if this X and Y position has been revealed and it's blank, then I will take every single adjacent tile to that and clear it as well. So now that we cleared out the blanks, I am noticing that there's a significant problem with this. If you want to get it on your own, pause it right now and tell me if you got it in the comments. But I'm noticing that on the edges, including the bottom and the right, the numbers are not always correct. This gives me a clue that I'm not showing the entire grid. I'm missing the right and I'm missing the bottom. All I needed to do to fix that was go to my love.window.set mode, and since we are indexing by 0 for our grid, I wanted to add one to the grid.width and add one to grid.height. Once your code roughly resembles the product you're going for, I recommend stress testing your code by trying to break it. For me, I would left and right click mines and the header. Doing this, I found that I could still dig out a tile that is flagged. Stress testing can also give you a path forward on features you think are next in line to be added. Things like highlighting the mine you hit, revealing mines every tick based off of RNG, realizing the problems with the chance-based mine revealing, and refactor your code to reveal mines based off of a timer with random intervals. Creating a function that acts like a dig because you realize it doesn't explode mines when you're doing an adjacent mine with a right click and a left click. There are going to be times when you realize that your code is not matching your vision, so it's okay to go back and refactor and make it work exactly like you want. Then if you continue that pattern of playing the game, finding something small to fix, or finding something small to add, you're going to eventually find yourself with a fully completed project that has some polish on it that's going to look really good.
Alright, so here's the gist of the game. It still shows me where the cursor is. It gives us a nice little quick and snappy animation to reveal the tiles. We have the ability to flag areas. We can mine. We could also do an area dig. Let me find a good example of that. These are not good examples, huh? There we go. We could see the it mined out the adjacent tiles that were not flagged. It's working exactly as I expected. So what I'm going to do is I'm going to leave a link down below to the GitHub repository for this. Let me know what you guys think about this new style of video. I was really excited to try something new on this channel, see if I could help someone out on their journey to becoming a software developer in one way or another. So if you guys feel like this is good and you deserve a rating, feel free to like the video and subscribe if you feel like it. And I hope you guys enjoy the rest of your day. Take care. Bye-bye.